Hey everyone, I am the Unemployed Artist, and in this video I am going to be showing you how to make an easy to hang wooden panel using a Shopbot CNC that I use at the Fuse Makerspace. I like using the CNC to make my wooden substrates over the more traditional method that I demonstrated in my last video because it's quick and consistent. The CNC also makes it possible for me to router out a pocket where I can install a cleat on the backside, making it easy to hang for display. The panel is also much thinner than the traditional method of making a panel. It's made out of just a single sheet of birch plywood, which is 3/4 inch thick. So it's incredibly sturdy and has better odds of not warping compared to other lumber cord plywood. So in this video I will go over how I create the design using the Vetric VCarve Pro software at Fuse Makerspace. Then I'll briefly go over how to set up the CNC. I won't show you the interfacing software that runs the CNC. That you should learn in person while also learning about the safety precautions when running such a dangerous piece of equipment. But I will show you the CNC in action, and I'll do a better demonstration on how to make a cleat for this panel than I did in the last video. So, if you guys are ready, let's get started. To begin, you need to open up the VCarve program and then select Create a New File. Next, you have to define the X and Y dimensions of your material. My board is 24 by 48 inches. The Y-axis is parallel to the gantry of the Shopbot. Then you need to input the thickness of your material, which you can do after measuring the two opposite sides of the material with calipers. After everything looks good, hit OK and proceed. The overall blank rectangle defines the parameters of material, which is 24 by 48 inches. I can now start defining the dimension of the panel I want to cut out by drawing a rectangle. I repeat this process by making a square, which is where I will put my cleat. Then I hit close and align my selected rectangles along their y-axes. Now I have to define what the CNC will cut, so I head over to the Toolpaths tab, select the square vector. The broken line means it's selected. Then I select the Pocket Toolpath tab. I know the thickness of my cleat is 0.46 inches, so I set that number as my cut depth. I'm using a 1/4 inch upcut bit, despite the fact that a downcut or straight bit would work better for pocketing plywood. I can then hit the Calculate button, and the program will render a 3D view of the pocket toolpath I just made. Everything checks out, so I hit close and select the tab that says New to create a new toolpath. I select the vector that defines the outer dimension of my panel. Select Toolpaths, and because I want to cut the shape out, I'm going to select the Profile toolpath. Originally, I defined my material as 0.732 inches thick, but I'm setting my cut depth as 0.731. Doing this avoids cutting into the bed of the table, and often leaves a thin lining of material that helps the vacuum of the table hold what I'm cutting into place. Then I preview both toolpaths and make sure everything looks right. I then select my two toolpaths and save to file as a .svp. I'm calling this file Most Awesome Panel. The very first thing I do when setting up the CNC is to install my bit into the appropriate collet and tighten the chuck to the spindle. I then secure the dust extraction skirt back on the spindle. I then want to home the X and Y axes. I do this by pulling the gantry along the X axis to the end of the rail, hold it there, and hit the reset button. I then use the Shopbot software to move the spindle away from the reset point so it can register its location. Then I can run the program that will automatically zero out the X and Y axes. After the X and Y are zeroed in the corner of the first quadrant of the table, I like to run the spindle warm-up program, which lasts about 9 to 10 minutes. Running the spindle warm-up program ensures that the spindle bearing lubrication is spread evenly and helps prevent wear while establishing a stable temperature. After I run the spindle warm-up, I then take the opportunity to retighten the collet chuck to the spindle, just for good measure before cutting. I can now zero the Z-axis using the touch-off plate. Off-screen, I've grounded the alligator clip to a nut just above the spindle motor. Once the X, Y, and Z axes are defined, I can jog the spindle home to its 0 point in the corner. I then position my material over the first quadrant on the bed of the CNC where the spindle is zeroed. I then close the PVC valves in the other 3 quadrants of the table that I am not using, which allows the vacuum to hold more sucking pressure for my material. Then I upload my file to be cut, preview it, and make sure everything looks good one last time. I ensure the spindle is on and running before allowing the software to cut my file. Then it proceeds to cut. Throughout the process of the CNC cutting into my material, I keep a watchful eye and ear to make sure the bit doesn't slip. This has happened before, which not only destroyed what I was making, but cut a deep groove into the table, therefore forcing the technicians to have to repair my mistake, which is pretty embarrassing. However, since I started retightening the chuck after the spindle warm-up step, I noticed I haven't had any slip-up yet. Knock on wood. Once the CNC is done cutting my material and the spindle stops moving, I turn off the vacuum and the dust collector. I then examine my material and you can see just how great my measurements worked out, leaving only a paper-thin lining of veneer in some areas. Because I used an upcut bit, you'll notice there's no chipping on the face of the panel. The veneer holding up my panel is so thin that I can cut it out with a box knife. I then carefully want to sand the edges, the back, and the front of the panel so that everything is smooth. Next I need to cut a cleat to fill the pocket of my panel. You can see here that the cleat material is completely flush with the backside of the panel, thanks to the precision of the CNC. To make a fresh cleat, I'm going to take some scrap 1/2-inch birch plywood and rip it down with a 45-degree angle cut at around 2.5 inches. Notice how I wear the correct personal protective equipment, and I have my push stick at the ready. You always want to be safe for yourself and for others. I also always wait for my blade to come to a complete stop before proceeding to the next step. I then measure my cleat material at 10 inches, which is the same diameter of the pocket that I cut into my panel. I proceed to cut my material to the mark using the chop saw. My first cut doesn't quite fit, so I trim off a little bit on the end. Now it fits great. But because the CNC bit is round in shape, so too are the corners of my pocket. Thus, I need to round the corner of my cleat if I want my cleat to nest nicely with the edge of my pocket. Looks good, right? The level certainly seems to agree. Once I know the cleat is level and fits snugly against the edge, I can apply wood glue and position it back into place. Because I'm using 3/4 inch brad nails, I want to shoot them in at a 45-degree angle so I don't pierce the face of my panel. I then need to cut my wall-mounted cleat to size, which I decided would be about 8 inches. That will leave some wiggle room to position and slide my panel left or right against the wall. I mark the wall cleat where I want to drill the holes and use a countersink bit so that the screw will be flush with the cleat when installing on the wall. I then want to do a final sanding around the whole panel, along with a quick vacuum cleanup, right before applying any primer. Finally, I can add some acrylic gesso, let that dry, and then it'll be ready for some paint. This panel turned out great. I hope you guys enjoyed the video. If you did, please be sure to hit that like button and subscribe. And let me know in the comments below what you hope to see in future videos. Until next time, thanks guys for watching, and I will see you later. Bye.